Yeah, let me briefly introduce George first, then I will pass the mic. So George, he has been positioned in critical roles for the design wins in the key customer products, and as a member of technical staff, he has contributed to the engineering part of business acceleration with involvement in applied research, technology scouting, innovation, and universities and standardization bodies engagement. So he's going to present in the seamless tinyML development and deployment of AIoT. So giving him with a big applause. Yeah.
I have a microphone already.
Oh.
Yep. Thank you. Thank you so much for the nice introduction. And definitely it's my pleasure to be here with this great audience. And yep, right to the beginning. So it's really the right moment. And I was hearing the presentation, the keynote speech from Mr. Huang, and I was feeling like that we are kind of organized, kind of synchronized on what we're going to be talking about. Why? Because really the first sentence of my introduction is that generative AI and large language model is definitely the trend, is more like the talk of the town. And obviously that is what was presented before. So I'm going to try to explain to you the AI and the ML on a different direction, on a little bit different way of doing that, like to the point of really moving to the far edge of AI and ML implementation, not by using large processors, but just simple MCUs or MPUs that allows to run AI tasks at the edge. And on that part, definitely goes and works well with the point of IoT, where AI comes and converts all together to make it possible to work on tiny sense and computer nodes to allow create impact on IoT applications. But if we really want to see that in terms of numbers, the data that overall is created exceeds 85% over and worldwide, and that in terms of actual size in memory exceeds the 80 zettabytes, which zettabytes means that we have at least 21 zeros in the moment. And taking this step further, that is definitely 90% of those data are never used by enterprises. So they exist, they live, they consume the memory and the space, but they don't have actual use, unless to the point that we bring AI in a way that can benefit of that and make those data meaningful. So looking on that part, exactly on that part, we're talking about the convergence of the technology like AIoT and AI and 5G, and they are really maturing roughly at the same time, creating what we call artificial intelligence of the things. And traditionally, that could be a cloud-based model for this level of intelligibility. Although the extreme edge and the endpoints in the network is be done in a way that we decentralize the way of handling those kind of data. And one step further, these kind of endpoints can run on simple devices like MCUs, the single core systems that allows to execute and still be using and executing the workload by making inference of the model. Another thing that happens is that, again, data exploration explosion is large, overall is very, very big, and creates the need for the inference engines to be able to use this data in the most efficient way. And that overall creates a new design mindset where we're trying to approximate in a way of figuring out what kind of driving challenges we have to address for exploring and having use of all this information. So, talking about decentralized intelligence, and let's see what are the benefits, what are the real benefits of this technology, and how we envision that in Renesas in a way of using it on end products. So there are definitely several IoT applications, and we all use them already, and we all know about them and how well they are applied in real life. And one of the biggest things is that we are able to reduce the latency, exactly because we can transform the data at the edge, at the source of the processing, without having to transfer them and wait until some transfer is completed to get the data, to get the result. And that results in a kind of time-critical applications that could help and could be further optimized when they run at the far edge of the AI technology. Looking one step further, we're talking about security and data privacy, because all the data can be kept locally, and there's nothing to do with transferring the data over any kind of network in order to allow and improve the privacy of this technology and the data that we're moving on. And definitely, for IoT devices, mostly those that we carry on with us, this kind of data are quite sensitive, and at certain cases we don't want to be transferred everywhere. One last thing is the network agility, and the part that really creates and goes to the point of having even power reduction, because running the inference at the edge does not require to have circuits and facilities able to transfer data over the network, just transmit, receive information. So overall, this is reducing the amount of power that the silicon is consuming. The way that we do see what edge AI does in part of the applications, but also on the key technologies, is applied in all the points that you see on the left side, like home automation, building automation, industrial, agriculture, transport, logistics, and other applications like health as well is included. And all of them, they carry key technologies that are very well known, and we have them and we hear them all the time, like sensor fusion, motor control, human-machine interface, and more things that are there. Really, on the part of the AI ML is where we can resolve the exact problems and make all these IoT applications to run in a way faster, better, more accurate in servicing our needs in a better way. And on that part, we have created three pillars, namely those are voice, where all the voice applications are applied, mostly on voice user interfaces and human-machine interfaces. Real-time analytics, where it relates with data and how we handle data coming from sensors, and of course vision, to the point that tiny microcomputing vision tasks can be implemented on the hardware that I have explained to you. So on that part, and moving forward, let me tell you a little bit of just the demos that we have outside to the next room, and they really reflect those three pillars that we have I have explained before. Starting first with an asset tracking, is an asset movement detection model that runs on an ARM Cortex 33 device that can go down to 100 megahertz, and believe me, we really have even smaller processors that can still run sufficiently this design. It takes a little bit more time, but this one is really fast and can detect movements like rotation, left, right, or even drop of the system. The other one is people detection, so it's a vision task that we have designed together with one of our partners, and detect people by using data from the camera and displaying them on an LCD that is on the device. And last is the voice control that relates with voice user interface, again together with co-development that we have with partners. We have designed a solution that can work and do voice control, really the first worldwide that can do voice control on an ARM Cortex M23, one of the smallest devices in the market that runs just at 48 megahertz. And on that part is doing the voice control, the voice commands recognition. It can also play back voice prompts and still leave some space for other applications like turning on off a light bulb, for instance. This is actually the demo that we have that we have outside. So it's not just this. It's AI is everywhere and impact our lives and is visible almost everywhere. There are a number of applications that can demonstrate the agility and the capabilities of the system that have to do with different controls at home or at the industry or inside farming infrastructure and more, and definitely more than that. It's more like the accessibility and the modularity of the application examples, and we have a lot of them. Many of them run on simple MCUs, but we also have systems that run on a little bit larger MPU level of the devices that we have in Renesas. So really starting from kind of 48 megahertz, one of the smallest devices that we have available, and we can go up to hundreds of megahertz for bigger devices also with AI accelerator like the DRP AI that can be used out of it. The portfolio that we offer as Renesas starts with the complete lineup of the solution. So we really consider how to collect data and how to understand the validity of this data, how important they are, analyze them, and with them we can train a model, and then at the end we can go down to the hardware to examine the inference. And on the part of sensing data, which is one of the largest in the market, mostly because of the large amount of sensors that are available, we're creating toolkits that can help on specific applications. And this is like the reality check anomaly detection. It's coming from the company that we have recently acquired, the Reality AI, and this team is heavily working on creating all these solutions and tools. So for anomaly detection, there is definitely the full flow of the operation. Anyone can take and start really from collecting data or using data, importing data into the system from any kind of known source, analyze them, get them down to the hardware and see how the hardware is working, and then reiterate on that part, because definitely those data and more data can be collected and more improvements can be made on the model or the system overall in order to operate in a more efficient way. Similarly for a reality check motor, it detects anomalies on motor control applications, and it can do it even sensorless, just by watching what happens on the current and the phases of driving the motor. And that system can run on our array families, which mostly the ARM-based devices from Renesas. The RX, which are custom 32 bits MCUs. RL78 is our 16-bit MCUs, and RZ are the MPUs that you can find ARM processors from the A family, so it's the large one, and together there can be additional hardware like the dynamic processor that we use for AI. And the same goes together with our own development on that part. So we have the AI SDK, the TVM, and the translator. And all these, they come together with a nice application that we call it eAI Translator, that can take any kind of model from known platforms that can design and train a model and compile it to be running on our hardware. On the last part of this slide, really on the right side, voice commands, we're mostly working with partners on that part, but we're following exactly the same structure. So the lineup of the solution is made in a way that you can collect data, in a way it can be really voice data, or having more like a text-to-model generator, and that at the end of the point, the system and the algorithms can be integrated into the embedded system and examined for the operation in very small devices like the array and the RX devices. Array is the ARM-based solution, 32 bits. RX is our custom 32-bit solution. So really looking on the next part on that, I want to a little bit talk about the AI ML solutions that we have available. And first, starting with a voice platform where we can support 44 languages, is definitely the full tool chain, which is scalable and has all the software infrastructure around it to be implemented in a few clicks away from creating a product. And that runs on M33 and M23 devices, depending on the size, requirements, and of course the cost, because you can imagine that the differentiation on the cost is important. But what I want to highlight is that this is a license-free development that is offered by Renesas, and this is the way that we work with our solutions and our partners up to the point of reaching end products. Then another part is the multimodal machine and access and personalization system. We call it multimodal because although we still talk about a system that runs on M33, really at below 200 megahertz, we can run up to 4 models concurrently that can do visual tasks like visual wake word detection, speaker identification, and face identification. And based on that, can take decisions on wherever to start the device, allow access, or just consider yourself being at your kitchen and the kids do not want to open the kitchen hoods. So some kind of personalization of the device allows to control without having any risk around. And part of our reality AI part, and it's the HVAC for refrigerator. This is a screenshot of how the data that are collected by the tool are getting analyzed. It's a complete end-to-end service, meaning that we start from the data and we really end up to a model that runs on a device and can do anomaly detection. And here is our very powerful team from Reality AI helps and can help every one of you to customize the requirements of this design by using exactly this tool set that really ends up on saving even a BOM cost, because the number of sensors that we are using is very important and the sensors are expensive. So we need to make sure that it's always important and the tool take care that the number of sensors will be the most optimal for this purpose. And definitely there are multiple IoT verticals. At the time that we were making this presentation, we were talking about more than 20 application exams that we have available. I can tell you that there are more than 50 the day that we're talking right now, and all of them execute on VRZ V12 systems, VRZ-V overall, and they are available for use right now and implemented, and they are public in our web page. So come in contact with us and you will find a lot of information around this part. So in order to summarize and give some key takeaways out of this operation, the first thing to mention is that definitely the convergence of AI and IoT is a megatrend and cannot be ignored. And there is where, at least from our side and the part of the edge AI implementation, or the tinyML implementation, where we're focused as Renesas. And that comes together with the thing that we all understand about the explosive growth of the data that get collected, and the need to address somehow those data really at the source where they're generated, instead of transferring them and having all this amount of of data be consuming connectivity resources. In Renesas, we are offering the hardware, but it's not just that. We're offering the software, the tools, and the ecosystem of partners that allows to work accordingly and help products become reality. So join us and our experts, and through our leaders from all over industry across Renesas AI, can present you and show you the latest innovations. And yeah, I mean, come to talk to us. We will be next in the next room for the full day, and we'll be happy to talk and address any concerns you may have on our systems, and also on the way that we work with partners. And mostly, by ending my talk, I want to give a big thank, of course, to the committee, but also to Not AI, which is hosting this my session. So thank you.